Hello, this is our first week of Java Programming 1, and we're going to be looking at Chapter 1 in our textbook. We're going to begin by just going through some basic concepts about programming in general and how Java works. Let's move forward here. Right, the objectives of the chapter are outlined here, and I know that you can read them in your book, and I'm not going to read them back to you. But we're going to look at the fundamentals of programming. Now, we do make the assumption that you've had some programming knowledge coming into this class, so I teach at a pace that recognizes that, so that you have some conception already. If you truly feel lost at any point, what I recommend is that you maybe look at some other foundational materials or read the material carefully to reinforce those concepts. All right, what's a computer program? Okay, I like that. Some instructions that accomplish a process. Computers are dumb machines. They're just machines. They do not know what to do unless we tell them what to do. Until they get smart, rise up and take over. But that's a separate issue. The truth is, we need to write the instructions that make the computers operate. And that's what programming is all about. Now, software falls into many different categories. We are going to be writing applications. We're not going to be writing system software, for example. We're not going to be coding Windows. We're going to be coding programs that run on top of the operating system. Now, computers only know how to communicate electronically. Electronic communications, by their very nature, are binary. You got a positive state and a negative state. We think of it as 1 and 0, on and off. The truth is, electronically, it's negative voltage, positive voltage within a certain range of voltage. And that's what computers do. Now, when you know your bits and bytes, and you've probably learned that in intro to programming at least a little bit, you'll know that, for example, a character on the keyboard is comprised of 8 bits of information. So a series of 8 characters, either being a 1 or a 0, and that possible range can generate 256 possible values, all the keys on the keyboards, plus a bunch of other control characters. So that's what the machine understands as those types of electronic pulses. Now, if we press one key on the keyboard and it generates a series of 8 pulses, the machine interprets that somehow and does something with it. And all of the code that runs in the machine and executes through the machine operates with that electronic mechanism. It's just a series of pulses. To us, it would look like complete gibberish. Now, our job as programmers is to make the machine do what it does, but we don't know how to talk the language that it talks. And when they say machine language, they're talking about really low-level programming language. I had the great fortune when I was first learning how to program. I won't tell you how long ago it was, but it was in the 80s. It was a long time ago. I had the pleasure of learning how to do assembly programming. Assembly programming is like one step above machine language. There are commands that are very simplistic. All the commands are 3 letters long and were accompanied by a 3-digit memory address. So you'd have a command like STO for store and then 003, which means store something in that position. And then you do all these statements like that, and I would write pages and pages and pages of code, and then we would execute it, and the computer would go beep, because it would take all that code to make the computer just make a simple sound, right? So while it was somewhat readable to us as programmers, it was a very simplistic low-level language. What we will be working with is a very high-level language. It's the result of many, many decades of development and refinement in the concepts of programming. And we're very fortunate in that capacity because we don't have to reinvent the wheel. We are building on top of the shoulders of those that have come before us, on top of the shoulders of the languages that preceded. And that's okay. We don't need to go to the machine level to be able to program. We can now abstract at a much higher level and accomplish much more with much less effort. All right, but it's important to understand that machines communicate in that fashion, that whatever commands we end up writing, they are interpreted by the machine at that level. The machine always operates on that level, no matter how we write the code. So we're going to write the code. It goes through a series of steps, basically called compiling, where it turns into a binary and then it's executable on the machine. Notice the name binary, right? We've converted it to ones and zeros that the machine can contend with. So the reason we use high-level programming languages is because they're comfortable for us to use, because we can read the code. Like, of course, you're probably still going to have some challenges reading the code, especially if you don't write good code. But it's much more English-like. All right. Some terms here. I got the term syntax. There's a rule set for every language. You're going to see that Java, unlike the Visual Basic or maybe the HTML and JavaScript that you guys have learned before, is a more common language structure than what you learned with VB. I always kind of have an issue with teaching VB as a foundation language. Although it is used pretty heavily out in the field, it's not really the prevalent development style. Languages like Java, which have curly braces and semicolons, are more prevalent, both on like the open source side of things and like .NET and the Microsoft side of things. So we're going to be writing a series of statements that will have the computer do certain things. Now, after we write our statements, we will compile the code. And what that does is it invokes a piece of software that's part of the framework that steps through our code and makes sure there's no mistakes, that everything that we're doing is valid. And if it passes, the program compiles, and then it's an executable, and we can run it. Now, just because it compiles doesn't mean it works, because you can actually write something that is syntactically correct, but doesn't do what you want it to do. All right, so that's one thing that you guys are going to learn, that things can be written correctly but still be wrong. Okay, and that's part of the fun of being a programmer. All right, so the compiler, some people will call it an interpreter, and that depends on how you're approaching it. Like, for example, if you're doing JavaScript, that's an interpreted language because it's interpreted on the fly. It's a non-compiled language, which runs in your browser. It doesn't need to be compiled. It just looks at the commands and does it. A compiler, though, literally does take the code and converts it to machine code so it can execute. All right, so you might run into the situation where you have syntax errors, and that's where you're not following the rule set of the language. Every language has a rule set, and you will learn these rules as we go. And there's certain conventions that you use, and I'll teach you some techniques to hopefully help you avoid those problems. Okay. Debugging, as it says there, it's really the process of going through and making sure that your program does not have errors, or the process of correcting those errors. Now, when we run a compiler and the code is not accurate, it's not syntactically correct, the compiler will throw an error. It'll tell you what it thinks the error is and the approximate location. The Java compiler is pretty accurate that way. Some other compilers really kind of aren't. It just depends on the language and the tool that you're using. But the Java one is pretty good. But you guys know where the word debugging came from? Did you ever hear this one?
Yeah, if I recall correctly, it was actually one of malls or something like that got caught in one of the major computer systems, and they couldn't figure out what was wrong with the browser. And they actually found that, was it moss, if I remember correctly, or something like that? They'd gotten in there and caused the issue.
Yes. And it happened to a system that was our first fully electronic programmable computer, which was called ENIAC. And that was in, circa 1946 or something like that. It was vacuum tube driven, not transistors or integrated circuits or anything like that. And you can see the guy right there. He's like playing with a bunch of switches and knobs and levers and plugs and stuff. And that's how they programmed the machine back then. They couldn't write out, there was no keyboard or mouse or printer or anything like that. It was literally just lights and switches. But they were having a problem. They couldn't figure out, well, everything's set up correctly, why isn't it working? And they found that there was a moth short-circuiting one of the tube sockets. So there was a bug in the system, so they debugged it. So that's where it comes from. A little piece of fascinating computer history. It's funny how things stick. All right, so remember I told you that you can have syntax errors, right? Or you can have something that is syntactically correct, but then it has logic errors. And you'll run into both, trust me. The ones that are more fun to figure out, I think, are the logic errors, because that's where the problem-solving part comes in, and the creativity and the thought process. So that's another thing we're really fostering here, is not just teaching you how to program, but the whole process of working as really an IT person. An IT person, by their very nature, and by the nature of the field that you're going into, is a problem solver, right? Jay, when you figure out a riff on the guitar, do you just learn how to do it instantly right away?
Oh no.
Oh no, you take it, you disassemble it. Right. It takes a while.
A lot of times too, I'll make notes and stuff like that.
All right, I'm going to pick on him a lot because we share some things in common for sure. All right. Now, when you guys are working in Visual Basic, you were working with an event-driven programming environment. So you were working with Windows Forms applications, right? Where you created a form, you put buttons and fields on it, and you click on it, double-click the button, and it writes a code stub, and you fill the code stub in, and it does whatever it does. Even though you're probably not aware of it as you were doing it, you were really working with an object-oriented programming language, although the majority of what you were doing was really what we call procedural programming, where it's a step-by-step set of instructions. And that still is a very important part of Java programming, because every component that you're going to write, no matter what it is going to have a series of steps. But Java is really best known for the fact that it's object-oriented and on a very high level. And everything inside of Java is either an object or a class. And I know when you first hear that, you kind of have this thought in your head that's like, I don't get it. My job is to help you get it, right? Because it is kind of a different way of thinking that breaks out of that systematic, do this, do this, do this, do that. Because we still do that, but we're treating things as an entity, a collection of parts that make a whole. You know, so that's the approach. Now notice here they have that little sub-bullet there where they have classes, and classes are blueprints for objects. All right, and I'm going to explain this as we go. And it says you create objects from classes, and then you create applications that utilize the objects and the classes. Now, I know there's subsequent slides here that I'm going to get to with some interesting diagrams. All right, but object-oriented has actually been around for quite a long time. There were some really revolutionary programming concepts that were happening even before we had computers powerful enough to really execute the capabilities. Like, for example, you know, I was just holding my mouse up to use it as an example of an object. Do you know when the mouse was invented? Well, it was in the late 70s, right? At Xerox Corporation. And they developed a graphical user interface with a mouse where you'd move it across and you'd click on stuff. And they thought it was, this is nothing. But Xerox Corporation also developed another interesting piece of technology, actually a programming language called Smalltalk. And Smalltalk was revolutionary. I mean, I can't even tell you how revolutionary it was. It was so advanced in its conceptions, both from like working with objects and classes, but also using some things that we use very commonly now, like model view controller architectures and things of that nature. So the concepts have been around a long time. They weren't really fully adopted until we got to the C-style languages, though. It was the C-style languages that identified the power of having this capability of having a blueprint and creating a replicant of it, or creating an object based upon the blueprint. And when we say blueprint, think of like when you're building a house, right? I draw it up on paper, work out all the details. These are the features. This is how tall it is and wide it is, and we're using wood floors and whatever it is that we're doing with it. And here's a blueprint. That's not an object. That's the blueprint. That's the class. The object is the thing that's built based upon that blueprint. So we build the house, and it has all the features that are identified in the blueprint. The class is the blueprint. The thing that we create is the object. And when we create an object, we call it instantiate. Okay? That certainly will be on a test. Hint, hint. Highlight. All right. So they're indicating here what object-oriented was used for. And they say computer simulations and graphical user interfaces. But not all object-oriented programs are written to use a GUI, and that's totally true. You don't have to use a graphical user interface to have an object-oriented program. Not at all. That's not how it works. The conception is that you have to be in a graphical environment to do something object-oriented. Not true. Not true at all. It says object-oriented programming differs from traditional programming with these key concepts, and these are very, very important concepts. We'll learn about each one of them in detail as we go, but they're techniques that allow us that once we have created objects, that we can utilize those objects in many different ways. So if I build a house based on the blueprint, I might also take this instantiated object and then maybe build a garage that goes with it. And that might pull some features from the house. It might be attached. It might draw power from the house. It might run plumbing to it. It might have the same siding, same roof, right? So we have these things that we might inherit, or things that have features that we can change, and that's what some of these topics are here. All right, so we talked about what a class is. And it says it describes objects with common properties. It's a definition, and it's an instance. Okay, so I still like to think of it more as like a blueprint. But that blueprint will have certain components. So for example, it'll have certain attributes that are associated with it. Is it a duplex? Is it a ranch, or is it a Cape Cod? Right? It would be different types. And then it'll also have capabilities. So it'll have attributes, and it will have things that it can do. So what can this house do? Well, this one's got 3 bedrooms, so we can put 3 kids in there, right? This one's only got 1 bedroom. Or a sliding door? Okay, a sliding door. All right, so we have attributes that are attributed to the class, and then once again, once we build something based on the class, it's called an object. The object, all it shares in common with the class is that use the class as a blueprint. So it really is an entity unto itself. Once it's created, it's its own thing. It's kind of like having children, right? Children inherit from you like certain things via DNA, good or bad, or both, but they really are their own person, even though they share certain attributes. All right, here's a little diagram. This is kind of helpful. Maybe we'll clear a few things up. Here they have on the far left a definition of a dog class. Now, think of that in sort of generic terms. Dog, right? I'm not saying St. Bernard or Chihuahua or anything like that. I'm just saying dog. Yeah, it's a dog. Well, what do dogs have? Well, every dog will have a name, an age, a breed, and a shot status. All right? Did they get the rabies shots, distemper, or not? So if we are to create an object, a version of dog, an instance of dog, we might create one that is an Akita, or a retriever, or a beagle. They're all dogs. They're all different breeds. They have different names. They have different ages. They have different status for their shots. They are their own unique entities, but all of them share in common what they brought in from the class. Okay, and folks, this is really kind of the essence of object-oriented programming. And I know that it's kind of like a kind of way out there kind of topic right now. And as soon as we start getting into coding, we're not going to be touching that for a couple of chapters, but then we'll be digging into a few chapters where we're going to start to work with objects, and you're going to see this come to fruition. And as we move to the end of the course, we're going to use that knowledge to build applications. And what you'll find is when you're building using objects, that the way that you declare things and the way that you utilize things within the language is beautifully elegant and simple if you've set things up correctly. So I'll be able to use a notation that might be like dog.breed.run, parentheses, because dogs can run, right? So when I create an object, I might go back to this and, okay, these are attributes, right? These are things that describe the dog. But dogs also have capabilities to do things. One of them is run, right? So things that can be done, or actions that we can take, things that we might call functions in other languages or subroutines in other languages, here we call methods. So the dog has a method, and that method might be called run, or stay, or sit, or roll over. So I can call upon that because the dog natively has that capability because it was built into the blueprint. And then because it was built into the blueprint, I can use that name directly as I'm declaring it without having to write out that command again. Okay, so it helps with the syntax, and it really is very powerful. So even though it's in the blueprint, when I create the copy, or when I create an instance of it, it inherits all those capabilities, and they travel with the object. All right. Encapsulation is basically talking about how code built using this approach doesn't necessarily have to be revealed unto either the user or the programmer necessarily. We're going to start creating programs that are going to be calling upon system libraries, for example, just to do input and output. And you'll just start using the commands and won't give it a second thought, oh, this is just how we do it. But the truth is, somewhere in Java, in the core libraries, there's a series of commands and objects and classes that were built to perform whatever action you're doing. We just use them. Now you're going to get to the point where you're building your own classes and objects and capabilities that you can just use. So when you start looking at it in that fashion, you're going to start discovering that Java has so much that's built into it, it's already done for you. You just have to figure out what those are and what they do. How do you learn all that? You learn as you go. I don't know them all. I know a lot, but I don't know them all. Start to do some pretty advanced stuff. I'm on Google looking like everybody else is. Or I'm at the the Java website, looking through the manuals, trying to figure out which command do I want to use, what do I want to pass to it, what's it going to do, and what's the result, does it work with this, does it work with that? And you figure it out as you go. So there's no embarrassment in this field that if you don't know something, that like 2 seconds later you're not on Google trying to figure it out or have some other strategy for figuring it out. That's what I expect you to do. You're sitting in the classroom with a computer in front of you and I ask you a question and you don't know, you're just going to sit there looking into space, or you're going to start typing into Google and figure it out. That's what you're going to do. Because if you were hanging out with your friends, that's what you would do, right? That's what I would do. All right, some more concepts. I think we talked about inheritance a little bit, and that is where we draw the capabilities from other objects. So I can have an object or a class, I can pull its capabilities in to create another class, and I can take those capabilities and build another class, so it can actually cascade down as well. And not only that, but we can take those capabilities and morph them into other capabilities with few lines of code once objects are created. It's a beautiful thing. All right. Java has been around for quite a while. Sun Microsystems was the company that originally developed Java, and Sun Microsystems got bought out by Oracle back in the 90s. And Oracle, if you're familiar with that company, they're a big database company, enterprise level databases. And they bought up a lot of stuff, honestly, but they are technically the owners of the language. So they're the ones that develop it. So if you need stuff for Java, downloads, information, you're going to end up at the Oracle website. Now it's interesting that Oracle also is the company that has MySQL. Do you guys know that? So even though they have the big enterprise database, they also have the open source database MySQL. So it's kind of interesting, I think. All right. Object-oriented language, general purpose, architecturally neutral, that's probably its biggest and most important feature. So, and I think I mentioned that before. Now, it does run on a number of different types of computing environments. It's also probably the most popular embedded language, meaning if you buy a device that has some sort of like microchip in it that performs some sort of function, chances are the software is written in Java. Like for example, the computers in your cars, right? Just about every car now has a computer in it, you know, running the fuel injection and, you know, all the logic systems in the vehicle, the error systems, the OBD thing. Most of that is written in Java. So it's capable of, as I mentioned before, running on just about any type of computer platform and just about any kind of device that has a microchip on it, provided you tailor the code to work on that device. Now the reason it is architecturally neutral, as you see in that third dash there on the first bullet, is that Java, unlike other programming languages, or unlike, I should say, some other programming languages, it runs on top of what we call the Java virtual machine. So in other words, it does not run directly on the operating system. If I was working in a Linux environment, the system level programming language for Linux is C. C allows me to actually directly address memory, allocate resources, and work directly with the kernel of the operating system. So at a very root level. The Java virtual machine sits on top of the operating system. So it's a piece of software, just like a regular virtual machine, if you guys are familiar with what a virtual machine is. And that environment resides on the computer, and when you execute a Java program, it's that piece of software that runs the program. That has some very distinct advantages. One is it doesn't interfere with the core functions of the operating system. So you can crash the Java program, crash the virtual machine, but the operating system is still running. Now there's disadvantages too, and one of them is because it's not operating system native, it can be slightly slower than something that is native. So if I was writing like video drivers or something like that, I wouldn't be writing them in Java most likely. Okay, so that's a little bit of a difference. But the fact that it runs in a virtual machine, now all the people have to do that develop this product is they write a virtual machine software that runs on any platform, and the Java program doesn't care where it is, it'll run. In the past, what we would have to do if we wanted to write for the Mac, we'd have to write one thing for the Mac, go to the other platform, the PC, rewrite the whole thing from scratch using a different language. That's pretty intense work, you know, it's not really easy work. So this is really powerful just for that reason. And one of the reasons why it's such a popular language. It is considered a high-level programming language. It is not machine code. All right, we're going to be using a lot of different software tools. We're going to start the initial demonstrations just using a plain text editor. And we're not going to do that for very long. And then we'll move up to an integrated development environment. You guys have worked with Visual Studio. Visual Studio is a pretty intense piece of software, but it's an awesome piece of software because it has all these tools built in to help make your life easier. It has IntelliSense, right? You start typing something and it guesses and it fills it in for you. It indents your code automatically. It color codes things, shows you where the errors are, underlines, highlights, all these different things. That's wonderful. I think that's a great thing. But in some ways, it kind of cheats you out of a learning experience. So what we're going to do is we're going to move from that primitive text editor, and then we're going to move into a simplistic IDE. And an IDE, just so you understand, it stands for Integrated Development Environment. You need to know that when people throw around that acronym. And that means it has the editor, the compiler, the debugger, all those tools built in, including a console so you can see the output of your programs. All right, so we're going to look at tools like that. So a simplistic IDE, and then as we move forward in the course, right around the middle of the course or so, I'm going to bring in some full-blown IDEs, and we'll look at a couple of them and start to use them, and you can see some of the advantages and challenges of working in those environments. The biggest advantage mostly is the fact that you have like built-in error checking that's a little bit more robust than you would get in a simple environment. And that helps to accelerate workflow. But I will tell you there is a learning curve. And my main purpose here is to teach you the language, not to teach you the tool. Because the tool, you can really use any tool you want, and there's many, many tools. If you want something that's as powerful as Visual Studio, there are some really excellent professional packages that cost thousands of dollars that do amazing things. But not everybody works with those. There's plenty of good free tools as well. But you need to get to know those. All right. Let's take a real quick look at this diagram here and how the language works. So you can see at the very top we have our source code. That's the stuff that we're going to type. The commands, there are curly braces and semicolons and system out print lines and all those things that we're going to be doing. We'll take that source code. Once we're seemingly thinking we're done with it, we'll compile it. The compiling will turn it into what we call bytecode. So it basically takes that information and turns it into a format that's a lot closer to what the machine can run. Then that will be sent to the Java virtual machine, where the interpreter will take that bytecode and convert it into a language that will execute within that environment. And this is an important thing to understand, what the levels are of this. If I was writing something that was native to the operating system on a machine level, like for example in the old days when we would do DOS programming, it would always be in BASIC because that's the language that was used to create the operating system. So that wouldn't have this level in it. It would just go from here right down to the operating system and execute. All right, so that's a little bit different. There's a lot of different ways that we can launch Java applications, and this very first bullet is the one that's basically disappeared at this point. Applets. Have you guys ever gone to like a website and it says you have to install a Java plugin and you install it, and then these days you discover that Chrome and Edge and Safari and all these different browsers, well, strike Safari from that mix. Firefox I think will still do it, and Safari will still do it, and Internet Explorer will still do it, but Chrome and Firefox, you really have to jump through some hoops and trick it in order to make Java run inside the browser. They just basically don't allow it, because really what you're doing in that environment is you're setting up a virtual machine inside your browser that can do anything it wants on the operating system. Highly insecure. So we've developed new ways to run Java and output to the browser. So those of you guys that were in PHP or ASP class, we'd write our code, it runs server-side, it generates HTML and pushes it back to the browser. We have techniques like that we use for Java as well. So we don't need to run the Java in the browser, we run it on the server and push it out to the client. So applets, for all intents and purposes, even though they're still kind of around, are basically done. It's really an antiquated approach. There are some people that still try to use it. Not recommended. The applications themselves, though, will fall into these two general categories, and that is console applications and graphical applications. And you can write both with Java. There's different tool sets that you can use. There's some older approaches to doing graphic stuff and some newer approaches. When we get to Java 2, those will be the ones that we'll be pushing on you, are the newer approaches. And those a little bit more mimic the Intro to Programming Visual Studio, Visual Basic approach, but even there you're more on the code level than you are working with visual tools. All right, so they're about to walk into some examples here. So I'm going to bring up our first look at Java code. All right, so this is really perhaps the most simple possible Java application code that you can write. You can notice that the whole program sits inside what we call a class file. So a program is a class unto itself. Remember I said a class is what we use to create an object? So we start at the class level when we build applications. So every application is going to have this declaration here. So we're always going to say public class. There are circumstances where you can actually skip public, because if you don't put it in, it's actually implied. So you might run into some old code on the internet where people don't have public in the front of it, but it's considered proper practice to put public or private in front of it. Now if it's going to run, it needs to be public. So whatever we name our program is going to be this little portion here. So these declarations, public class, and then the name of the program. Notice that the first letter of the program is uppercase. It must be uppercase. Otherwise it will not compile. Once we declare the class, we have an opening curly bracket and a closing curly bracket. Everything inside that program's got to sit inside those curly brackets. Inside that class file, we now have another component here, which is known as the main method. So this string of characters that you see here, public static void main string square brackets args, you're going to memorize that. You're looking at it right now going, I'm going to memorize that? Yes, you are, because it's going to be a very important part of your Java programming. The main method, really identified by the text in black here. We know it's a method because it has a keyword identifier and parentheses that follow. So whenever you see the name of something followed by parentheses, that automatically indicates it's a method. And a method is something that does something, like a function or a subroutine in Visual Basic. But the main method in a Java program is the component within the program that will automatically execute when you launch the program. Now it is possible to write a Java program that does not have a main method. But if you want something to execute, the code's got to be inside those curly brackets. So you have the public class that holds the whole program. Inside of it we have the main method where we're going to put the statements that are going to execute on program launch. You launch the program, whatever's in that main method is going to execute. Okay? So sometimes what I'll see as a problem with initial programs that people write is like, roll the code, it looks right. Yeah, it looks great. You just didn't put it inside the main method, so it's not going to do anything. It even compiled. And that's one of the things you're going to look for. So that is, your most basic little Java program. All right, folks, I think this is probably a really good point to consider stopping for the night, especially since we have just a few minutes left. And then what we're going to do is we're going to pick up at this point next week, and we're going to dig into coding. So what I'd like you guys to do, the people that are here in class, is to make sure that you have your equipment with you, and we'll probably begin by making sure that you have all the components that are required installed in your machine, and making sure that it all executes. We'll try some simple programs. Then once we have your development environment all set to go, and you learn the procedures for it, then we can really dig into the coding. All right, this video ends here.